Brianna's teacher asks her which of these three expressions are equivalent to each other. We have the expression 9x minus 3x minus 4, 12x minus 4, and 5x plus x minus 4. Brianna says that all three expressions are equivalent because the value of each one is negative 4 when x equals 0. But Brianna's thinking is incorrect. Identify the error in Brianna's thinking. So again, Brianna says that all three expressions are equivalent because the value of each one is negative 4 when x equals 0. So we have choice A, where Brianna did not find the correct value of each expression for when x equals 0. Well, let's see. If we substitute in the value of x equals 0 into each expression, let's see what value we do get. So the first expression, we have 9 times x, so instead of 9x, we'll replace and substitute that variable with 0. So that would be 9 times 0, then minus, instead of 3x, we'll have 3 times 0, and then minus 4. So 9 times 0 is 0, 3 times 0 is 0, and minus 4. So 0 minus 0 is 0, minus 4 is negative 4. So we do get the value of negative 4 in that first expression when x equals 0. In the second expression, if we substitute in x equals 0, that would be 12 times 0 minus 4, which is 12 times 0 is 0, and 0 minus 4 is negative 4. So we get negative 4 as well when we substitute in that value of x equals 0 for the second expression. For the third expression, let's do the same. So we would have 5 times 0, then plus 0, and minus 4. 5 times 0 is 0, plus 0 minus 4, and 0 plus 0 is 0, minus 4 is negative 4. So all three expressions do equal negative 4 when x equals 0. So Brianna did find the correct value of each expression when she made the substitution. So that's not an error in her thinking. She is correct that each expression is negative 4 when x equals 0. Now, option B says that she chose the value of 0 to substitute for x in each expression. That was her mistake. Well, if we're trying to see the expressions are equivalent, when we made that substitution x equals 0 into each expression, we did get the same value for all three expressions. That does show that all three expressions are equivalent when x equals 0. So x equals 0 was a great value to substitute in for x because it does show that equivalence. It supports her argument. So that's not an error in her thinking. But then we come to option C, where it says that she only checked the value of each expression for one substitution of x. Again, she picked when x equals 0. But there's no rule that says that x must equal 0. In fact, x is a variable that's representing any value. Brianna only checked when x equals 0. She needed to check when x equaled other values. What if x equaled 1, or x equals 5, or x equals negative 5, right? We don't know those values. In fact, if we choose one of those other values, we'll see that the expressions are not all equivalent. For example, let's start with when x equals 1. So if x equals 1, the first expression would then be 9 times 1 minus 3 times 1 minus 4, which is 9 minus 3 minus 4, which is 6 minus 4, which is 2. So when x equals 1, the first expression is equal to 2, or has a value of 2. Now, if we substitute in x equals 1 in the second expression, that would be 12 times 1 minus 4, which is 12 minus 4, which is 8. Right away, the first and second expressions are automatically not equivalent when x equals 1. We have the first expression has a value of 2, and the second has a value of 8. We don't even need to see the third expression to see that they're not all going to be equivalent to each other. So that is the mistake that Brianna made. She only checked the value of each expression for that one substitution of x when x equals 0. So that makes our answer choice C.